By the end of the lesson, I will be able to evaluate fractions containing variables. 3 things that you need to keep in mind. When you see order of operations with a fraction bar, you need to use the order of operations to simplify the numerator, use order of operations to simplify the denominator, and then you're going to simplify the fraction. So we're going to evaluate number 15 if A equaled -4 and B equaled -6, and then we're going to write it in simplest form. So all I'm going to do is substitute in. So my A value is -4 and my B value is -6. I cannot divide 4 divided by 6, so what I'm going to do is simplify. A negative divided by a negative is a positive. And then I can write this fraction in simplest forms by dividing the numerator by 2 and the denominator by 2. So my final answer is going to be 2/3. Evaluate this fraction with variables using the same integers. So A is 4, I'm substituting, plus 9, and B is -6. So I'm simplifying the numerator. -4 fighting +9. Positives are going to win by 5. And then I have a -6. I cannot reduce this fraction. However, I'm going to bring my negative out front. So I have a -5/6. Evaluate this fraction with variables using the same integers. My B value is -6. My A value is -4. I have 3, and then A is -4 again. So I'm substituting and then I'm solving or simplifying. So -6 and -4 is -10. They joined. 3 times -4 is -12. A negative divided by a negative is a positive. So I have a positive 10/12. I'm going to divide both of these by 2 and to get 5/6. 10 divided by 2 is 5. 6 divided by 2 is 12 divided by 2 is 6. Evaluate using the same variables. So I have 2. My A value is -4. My B value is -6. And then it's all over 20. So I'm going to use order of operations. I need to multiply before I can add. So 2 times -4 is -8. -8 plus -6 is, they're going to join to get -14. I'm going to reduce this by dividing the numerator by 2 and the denominator by 2. I'm going to bring my negative out front, and I have 7/10. So I have -7/10. Using the same integers, I'm going to substitute. I'm going to use order of operations to simplify the numerator and then the denominator. So -6 plus 7. Positives are going to win by 1. 2 times -4 is -8. Nothing to simplify except that I'm going to bring my negative out front of my fraction. So I have -1/8. Last one, -4 and -6 for A and B. My B value is -6. My A value is -4. Do you notice that this is subtraction, and I also had to make sure I had my negative. So I have my subtraction and my -4, and I have 3 times -6. So if my integer hill is not positive, I need to change integer hill to be positive, and the guy to the right is a SPI. So my negatives are going to win by 2, and 6 times 3 is -18. I'm going to divide the top. Well, let's get rid of our negative first. A negative divided by a negative is a positive. And then we're going to divide both of these by the GCF, which has been 2 all the way through these problems. And so I get 1/9. Here's a little bit harder one. We have 3 variables and I have a fraction with variables. So I'm just going to substitute like we did with the two variables. So I have 3, my x value is -1, and my y value is 4, and my z value is -2, but I have a -2. So on the top, I'm going to simplify using the order of operations. So -1 times 3 is -3. 2 times 4 is 8. On the bottom, I have an imaginary 1 being multiplied by the -2. So I have a +2. A -1 times a -2 is a +2. Simplifying the top, -3 plus 8. Positives are going to win by 5. And my denominator is 2. We're going to leave this as an improper fraction. I do not want to see any mixed numbers. So my final answer is 5/2. Simplifying, we're going to substitute. My x value is 3. My is still 3 and plus 6. And then on the bottom, I have 3 plus 3. So order of operations tells me that I need to do parentheses and then exponents. I don't see any parentheses, so my exponents 3 times 3 or 3 squared is 9 minus 3 plus 6. 3 plus 3. 9 minus 3 is 6 plus 6 is 12. 3 plus 3 is 6. If I divide the top or the numerator by 2 and the denominator, or I'm going to do it by 6. Divided by 6, that's the GCF. 12 divided by 6 is 2 and the denominator is 1. So how can I write 2 over 1 as just a whole number? And that is 2. So sometimes it will just be an integer whole number.